Today we are going to learn how to find the greatest common factor of two or more integers. We will learn three methods. The first method is a naive method. Let's find the greatest common factors of 48 and 60. First, we list all the factors of 48 and 60 because 48 can be expressed as 1 times 48 or 2 times 24 or 3 times 16, 4 times 12, or 6 times 8. So we see there's 10 factors for 48. For 60, we can express it as 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. And then we circle common factors. 1, 2, 3, 4, 6, and 12. So you see 12 is the largest or greatest common factor for 48 and 60. We can also use another method called ladder method. So let's solve the same question. So greatest common factor of 48 and 60. So put them on a row. 48 and 60. We know 4 is a common factor. So 48 divided by 4 equals 12. 60 divided by 4, 15. We know 3 is a common factor for 12 and 15. So 12 divided by 3 equals 4. 15 divided by 3 equals 5. At this point, we stop because 4 and 5 have no common factor greater than 1. And the GCF equals the product of the number on the left side. So equals 4 times 3 equals 12. See, we get the same answer. When we are given some large numbers or given 3 or more numbers, the ladder method would be more efficient. Let's look at another example. Let's find the GCF of 36, 54, and 72. Again, we write them on a row. So 36, 54, and 72. We know 2 is a common factor. So 36 divided by 2 equals 18. 54 divided by 2 is 27. 72 divided by 2 equals 36. we see 9 is a common factor for all of them. So 18 divided by 9 equals 2, 27 divided by 9 equals 3, 36 divided by 9 equals 4. At this point, we stop because there is no common factor greater than 1 for all of them. Although 2 and 4 has a common factor too. And the GCF equals the product of the number on the left side. So equals 2 times 9 equals 18. We can also use another method to solve this problem. This method uses prime factorization. Factorization. So first, we find the prime factorization of 36. 36 equals 6 times 6, and 6 equals 2 times 3, 2 times 3. So we get 2 squared times 3 squared. 54 equals 6 times 9. And 6 equals 2 times 3. 9 equals 3 squared. So we get 2 to 1. And 3 to 1 times 3 to 2 equals 3 to 3. And 72 equals 8 times 9. So 8 equals 2 cubed times 3 squared. You can write one more time. Okay. 2 cubed times 3 squared. We look at those prime factors common to all numbers. So they are 2 and 3. And we pick the lowest exponent. So for 2, which is 2 to 1. Yeah, this one. 2 to 1. For 3, the lowest would be 3 squared. Then the greatest common factor would be 2 times 9 equals 18. That is the greatest common factor of 36, 54, and 72. Finally, let's look at an application of the greatest common factor. So let's see, let's simplify a fraction. The fraction 294 over 420. First, we find the prime factorization for 294. So 294 equals 2 times 147, and 2 times 147 equals 7 times 21, and 21 equals 3 times 7. So finally, we get the prime factorization 2 times 3 times 7 squared. For 420, we find two close numbers. The product equals 420. So 20 times 21, and 20 equals 4 times 5. 21 equals 3 times 7. So we get 2 squared times 3 times 5 times 7. You see the prime factors common to both numbers are 2, 3, not 5, and 7. And again, we take the lower exponent. For 2, which is 2 to 1. For 3, again, 3 to 1. For 7, 7 to 1. The product would be the greatest common factor, 42. To simplify the given fraction, we divide top and bottom by the greatest common factor. So 294, 420 equals 294 divided by 42, and 420 divided by 42. The bottom equals 10. The top equals 7. So the given one equals 7/10.